This is Jeff Mucci from RCR Wireless News. Today we're meeting with Arpit Joshipura, VP of Strategy for Ericsson. Arpit, thank you so much for joining us today.
Well, thank you for having me here.
Yeah. So why Silicon Valley?
It is a very interesting place to be, first of all, because it's the innovation capital of the world. But if you take a couple of decades view, internet was created here in the Valley, and mobility was, for most part, invented in Europe,
right.
Whether it's Sweden or Finland or whatever. Well, the two worlds are merging now, and it is critical that we, Ericsson, as the largest infrastructure player, are in Silicon Valley, where a lot of devices and applications are trying to get onto the internet. So we're bringing the best of both worlds, mobility and internet, as a leader in convergence.
Okay. And in your role as VP of Strategy and Market Development, you're in a corporate role for Ericsson.
Yes, that's correct. That is correct.
And you report to whom?
I report to the CTO of Group CTO of Ericsson, Håkan Ericsson, who is now the new head of Ericsson Silicon Valley, along with his Group CTO role.
So he's moved here as well.
He has moved here as well, and so has Dr. Jan Udenfeld, who was the previous CTO of Ericsson. So you can see the commitment Ericsson has on Silicon Valley, and the importance of the next decade.
A lot has been made of the internet in 1999, right? And clearly Silicon Valley led that effort. And then you've heard people talk about the mobile internet. And we're starting to see the convergence of those two meeting. What is Ericsson's position on where the internet is meeting mobile?
First of all, the networks are separate today. The mobile network is separate, and it's architected for voice predominantly with 4 billion phone connections. The internet, predominantly fixed, driven by U.S. in general, has been architected for, 500 million or so connections. The fundamental difference between the two networks is that the fixed network was architected for cost per bit. Right. And it was optimized for the house or the business.
Or the enterprise.
Or the enterprise. Yeah, business in terms of enterprise, right. The mobile network was architected for scale.
Right.
Mobility, obviously. But more importantly, interoperability, right, with different devices and different standardized way of doing things. And I think what is happening is, with the convergence, we believe that when we go to a vision of 50 billion connections by 2020, majority of these connections will be mobile.
Right.
And in order to bring a converged network, mobile values will prevail. And these values are, again, personalization. It's my device, not a connection to a house or a building. Scale. It's a tremendous scale that the networks have to handle. Interoperability, because you cannot have these vertical silos for long. It's good to get it started, but you do need interoperability between all these devices. And I think that is our position when it comes to Ericsson for the next 5 to 10 years when these two meet.
Okay. Over the last year, a lot has been made about Ethernet backhaul as being an acute problem, and I think that's getting solved with IP and Ethernet type radios and fiber to the tower, so I think that's going to work itself out. And of late, you've been hearing a lot about deep packet inspection. Cisco bought Starent, Telabs bought Y-Chorus. What is Ericsson's deep packet inspection strategy?
Okay. So let me handle both the backhaul and the deep packet inspection. They're kind of separate from a networking perspective. We have defined backhaul as a low RAN and an HRAN, or a high RAN. Low RAN being the first mile, and the HRAN being the metro network.
Right.
In terms of the backhaul, we here in U.S. have a particularly interesting problem because we don't have microwave. Worldwide, if you look at it, 60% of the backhaul is done through microwave.
Right.
And, we have the majority of the market share there in terms of, microwave over Ethernet, obviously. The remaining, 20% each is copper and fiber being more in China, copper being more here. And slowly what's happening is the trend is either going towards microwave or going towards fiber.
Right.
And as you well say, it will sort it out, right? And the backhaul will be upgraded as these networks get more fiber into and close to the base stations. So that's the backhaul. What we believe differently on the next hop up is we need a unified metro network which takes in not just the backhaul traffic, but also the fixed residential and the fixed business enterprise traffic. And you take that whole in a common metro network, and then you hit the edge where deep packet inspection happens. Right? So now in the edge of the network, which we call IP edge, what Ericsson has done very uniquely is we have had a couple of acquisitions over the past several years. The one specifically relevant in this instance is the Redback acquisition.
Right.
And what we have done is the Smart Edge product that has been acquired has been taken and integrated into what we call a converged packet gateway. So the best of Ericsson's mobile software and the best of the fixed deep packet inspection as well as the routing platforms from the Smart Edge, they're all now running simultaneously on this general purpose computing platform. So in terms of deep packet inspection, in the mobile space, we already have deployed products worldwide that do heuristic-based analysis to prioritize traffic. And that is allowed in the rest of the world. It's kind of, an issue here in the U.S. But worldwide, it's one of the most widely deployed products as part of our packet core offering.
Okay.
But as we move to 4G, it is important that this function gets integrated into an IP Edge platform.
Okay.
And that's based on Smart Edge.
So you see a surge of data, which is driving up the cost, both CapEx and OpEx for the carriers. They don't have revenue streams to really recoup that investment. With microwave and fiber, they'll decrease their backhaul cost. What's the ROI for them in the deep packet inspection area?
The ROI it's in fact simpler than than a pure business case, because every statistical analysis or every plug we put into our routers to measure traffic show that, and you can take it anywhere. It's different in different countries, but about 80% of the traffic is created by 20%.
Okay.
Sometimes it's 90, sometimes it's 70. But if you take that rule, that you're targeting the 10% of those users who are generating a lot more traffic. In the rest of the world, there's a cap you can put on it, because you can immediately segment them and then take it into a stream where you are prioritizing them, not blocking them, but as a best effort.
Right.
So the strategy we have used is fairly simple. Instead of blocking, you just prioritize the traffic that you really need.
Okay.
And that is value generating, revenue generating, jitter, delay, sensitive traffic. You just let that go. The rest of it just becomes the best effort internet, which is what it started to be anyway.
Right. Okay. 3G networks were optimized for voice. In this all IP architecture, one of the questions I have is, when I pick up the phone, that's a 4G type of phone, 3D LTE type of phone, and I hit the base stations, where is the data versus voice separated in the network?
So I think you said 3G. I would probably start off with 2G.
Okay.
Right? They were optimized for voice, right?
Yep.
3G, there's a lot more data, and we're seeing a lot more PC cards and smartphones coming over 3G networks, right, worldwide. So it is optimized for data. The 3G networks have, from a standards perspective, have been built in such a way that you take in the voice and data, and then, between the radio base stations and the packet core, you split it out in
Right.
such a way that it hits the internet.
Mm-hmm.
Now, there have been standard enhancements, and for example, Telstra in particular, Australia is one of the leading mobile broadband deployed carriers, 21 megabits. They have deployed something called 3G direct tunnel, or fast track, if you may, in a simplistic manner, where you hit the internet a little bit sooner, quicker, both physically
At
and
the radio
logically.
level, or at the tower level, or at the mobile switching center level?
It's after the tower, right?
Okay.
So you can't. I mean, air is air, right?
Yeah.
So it's after that, because at the end of the day, when base stations connect to the backhaul network, it's a physical Ethernet plug, right?
Yep.
I mean, the airwaves have to hit the ground, and our job is to it's a very simple strategy. You need to get fastest path to the antenna, whatever it is, right? Whether it's a GPON or
Right.
a tower or a Wi-Fi connection. That's the first job. The second job is get to the internet as fast as possible once you're coming out on physical Ethernet. So those two things help in the deployment. And different operators do it differently. Right? Not everybody uniformly operates it.
So is the edge, does it become at the tower level, literally on the ground at the tower, or is it back in the core at the switching center? Where is the edge, the IP edge?
So today it is centralized.
Right.
And one of the fundamental shifts that we are seeing in the network is that the edge is starting to get distributed closer to the tower.
Right.
And the reason for that is very simple. Right? If you take an analogy of the fixed network, so you might remember, dial-up, right? We used to dial in, kilobits of bandwidth, downloaded our emails, we were done. So what the edge required was a lot of subscribers, but very low bandwidth.
Yeah.
And you could do it centralized. The same is true for what we call, 2G, 3G, early 3G networks, or even, edge as an email, kind of a BlackBerry kind of an email things, right? Lots of subscribers, low bandwidth, you centralized the core, right? In the world of 3G and 4G, where devices and dongles are always going to be on,
Right.
they're always going to be connected. They're doing a lot more streaming, a lot more downloading, multimedia content. The requirements for IP edge move close to the access,
Right.
both on fixed and mobile side. And that's a trend we are seeing. Now, do they get all the way into the radio base stations? Remains to be seen. But will they be centralized in 2 POPs in a country? No. They will start getting distributed into the metro. And what you effectively do is you terminate and you give services and you give personalized services to a subscriber as close to their origin as possible.
Do you think you'll ever see a router at the base station level? Not at the tower, on top of the tower, but down in the rack?
There are equipments not running full layer 3 routing,
Right.
but running enough IP intelligence, if you may, at the base stations itself.
Good.
Okay. So and we have a strategy to sort of align that so that whatever can be done from an IP perspective in the radio network should be done there. Whatever can be done in centralized, like legacy is all centralized, and then everything else becomes distributed in the middle.
Okay. 2 other areas I want to explore.
Sure.
Number 1 is the what other trends you see in internet mobility.
Okay.
And then number 2, Ericsson has made a major investment in a presence here in Silicon Valley. Talk a little bit about the ecosystem you're building here in the Valley.
Okay, so internet mobility trends, first of all, different predictions exist. Okay, Ericsson's vision is that by 2020, there will be about 50 billion connections. Now, we have done some consumer research. We have talked to our customers, operators. What does it really mean? And what it really means is anything that can be connected to the network will be connected. And there are 2 reasons for that. One is the cost of connectivity in terms of chipsets and modules and things that actually, the radio part of it has definitely gone down.
Mm-hmm.
And then the second part of it is the need to get these devices connected has gone up.
Right.
And whether we go into verticals like autos or government or utilities or health, that is just a question of country predictions.
Mm-hmm.
But traditionally, the devices that we are all used to, phones, laptops, those will keep on going and growing,
mm-hmm.
right? But now we're looking to see a lot more verticals come on to
right.
the mobility. And this is enabled by mobility. It's not, internet has existed for quite some time now, right? But why did all these things not come on to it? Well, mobility was missing.
Right.
Which leads me to my second answer to your question, which is, what are we doing in Silicon Valley?
Sure.
And I started off by saying, we have mobile phones were pretty much a Europe phenomena.
Right.
And internet was a Silicon Valley phenomena. And now when you bring the two together, what you still have here is you have a large community of application developers, a large ecosystem in terms of venture capitalists,
mm-hmm.
universities, startups,
mm-hmm.
right? So that's a whole crew of people that will think of the next best idea that can be enabled by a mobile infrastructure.
Right.
So that's the first part of the ecosystem we are working with very closely
mm-hmm.
as Ericsson. The second part of the ecosystem is the traditional, now I can call them traditional device companies, Apple's, Google's, the Android operating system, etc.
Right.
Which now become even more relevant as they come on to the internet, right?
Mm-hmm.
And they come on with more high capacity, high intensive applications, right?
Mm-hmm.
And then there's the third segment of the ecosystem which we always talk about, which is the other large players that have a role to play, whether it's the servers and from Oracle or Sun, or whether it's the chipsets and processors or the mid devices from Intel,
right?
Or modules and laptops and things from HP and Lenovo
mm-hmm.
and IBM
mm-hmm.
and other manufacturers.
Mm-hmm.
So from an ecosystem perspective, our joint ventures, ST Ericsson and our chipsets, have been powering a lot of 3G laptops
mm-hmm.
that are coming out in the market.
Mm-hmm.
We have also powered things like the ebook reader from Sony
right.
with the 3G chipset.
Mm-hmm.
And so what we need to do from an ecosystem perspective is work with these players to make sure that the end user experience is what is needed in the next 5 years, right? Because there is a vacuum in Silicon Valley when it comes to mobility, right? Internet is fine, but that's a high bandwidth plug that's always on,
right.
and you throw bandwidth at it and you're done.
Right.
Mobility is not that straightforward, right? I think in one of the FCC speeches, he's described it as the oxygen of
right.
mobile broadband, right?
Mm-hmm.
There's only limited spectrum.
Interesting.
So and there's only so much processing you have to play with, so you cannot abuse the mobile networks.
Arpit, thank you so much for your time.
Very good, thank you, and appreciate you having me here.
Right.